Hello, I'm Anna Mackay, and this video is on discovering integrals. It's a unique technique that we use for particular types of questions. So here's the theory, write this down. If capital F dashed of x, so the derivative of that is f of x, so that's its derivative, then logically, if you integrated this one and went backwards, then they would be equal. You would get this function with the integration constant plus c. So here's that written out. Therefore, the integral of this one here, f of x, is capital F of x plus c. Seems logical? Let's put that into practice and I'll show you how it can be used. Alright, so here's a function here. If y is equal to this, find dy by dx. Full stop. So you have to do that bit first. Hence find the integral of this. Now, just a couple of points. See how there's brackets here? We don't always, well, we technically should have brackets all the time, but we sometimes get lazy and drop them off. Now, if you were to think about the integral of this, what would you get? Integrate that one, x to the power of 4 on 4, so raise the power by 1, put it over the power, and 3x to the power of 2 on 2. Now let's have a look at this over here. Well, this function's looking similar. We said to the power of 4 and 2, but these numbers, these coefficients don't quite match. So you can see perhaps why we need to follow this process. So there's a very set process for this that I need you to follow each time. Follow the instructions. Find the derivative. So let's do that. dy by dx, you take this y function and differentiate. So bring down the power to get 8x to the power of 3, and then bringing down the powers 24x. All right, so there's your first step. Now the technique is to use this rule. You now integrate that derivative and put it equal to the function that you started with. Do this before you do anything else. So you now rewrite that exact same derivative with an integral. So the integral of 8x cubed, take 24x, now put the dx on the end, is equal to the function that it came from. 2x to the power of 4, take 12x squared, and plus c. I'll do it in red the first time. So that's the technique that you need to do. Now you can go on to the second sentence. Hence find the integral of this. So they're going to connect. So have a look at this one and then have a look at the integral that you've written out. Okay, they're similar, but there's these coefficients here. Is there a common factor to those coefficients? Yes, a factor of 8. Now, as one of the rules in the previous video said, if you have a coefficient, a constant, you can shuffle it out the front and it will still be the same integral. So that's what we do. We don't put equals again. If you want to put something at the beginning, put a therefore. So I'm going to put a therefore. I'm going to factorise out that 8 just to show you what I'm talking about. X cubed, take 3, 8, 16, 24, yep, dx. So the right hand side is not changing each time at the moment, so we're just rewriting that. Now the rule is that 8 can be moved out the front. So 8 on the other side of the integral sign. Note that I got lazy and dropped off my brackets. And the right hand side has not changed. Now we're getting closer to what the question's asking us. It wants the integral of this. Okay, well, we've got the integral there, but we've got this factor of 8. How can we get rid of that? What should we do to that? Well, this side's being multiplied by 8, so do the inverse. Divide by 8, but you have to do that to both sides. So you can technically times through by 1 on 8 or divide each term by 8. So it's gone from the left-hand side now. So we rewrite that one out. And we put each term over 8, not just the first one. So 12x squared over 8. Now, I'm just going to write plus c, and I'll explain why. You could do c over 8, but let's think about that. C is a constant. So if you have a constant divided by 8, what have you got? You've still got a constant. So whenever you do one of these types of questions, you don't have to do that operation, the divide by 8. You can just leave it as plus c every time. We know that you understand what's happened. So I had some technical difficulties with my iPad there. Hopefully what you see on your screen is the same as what we had. So as I was saying, you can do a C with a subscript 1 if you like, to imply that C has had a change to it, but you really don't have to. So finishing off our question here, we're going to simplify the right hand side. So the integral of x cubed, take 3x dx is equal to 1/4 x to the power of 4, take away 3 on 2, x squared plus c. So that's the end of that question. And we're going to do one more here. So by considering the derivative of this function, find the integral of this function. So maybe have a think first, how could you integrate that? You might be saying to yourself, okay, x, increase the power by 1 on the power, and e to the x, well, the integral is the same. And that would be the case if they were separate terms, but they're one term. We don't have rules for how to integrate that. So this process is going to take you through it to see how we can do that. So first of all, consider the derivative of that. I'm going to write that out as a y equals function. So we've got x e to the power of x. Do the derivative of that. So let's write it in the terminology that's asked for. And the derivative of that, well, we've got product rule here. So our first function is x. Differentiate that, you get 1 times by e to the x. And where you add it, and now you leave the first function and you differentiate the second. And so that's what we're going to get. There's our derivative. And now the technique for these types of questions is take your derivative and write it as an integral and put it equal to the original function. So let's do that before we do any more. The integral of the answer that you just got with a dx on the end is equal to the original function, the original y, x e to the x plus c. Okay, so now start having a look at the second part. We need to find the integral of this bit. We'll have a look here. Well, there it is there, but it's got this extra e to the x attached to it. Now, if you remember back to the properties of integrals, we can split integrals. So we can integrate that and add on the integral of this part. So let's do that first. So we're going to split this integral up. So the integral of e to the x plus the integral of x e to the x dx both times is still equal to what we had, the right hand side before. Okay, now you're actually allowed to move this integral across to the other side of the equals, and then we'll be left with the part that we need. But we will have to work out the integral for e to the x. So we leave the right hand side as it is. We tend to put the moved integral in here. Notice that it's become a subtract. It's still plus c. And now the last part is to integrate e to the x. So what's that? The integral of e to the x is e to the x. So we write all of that out again, and that is the integral that we're after. So the integral is e to the x plus c. So there we are. The integral of this function here turns out to be that. Okay, so that's a technique that you need to remember, and that's the end of the video. If you liked it, give it a thumbs up and subscribe to the channel. And the next video in the series will be looking at upper and lower rectangles. Thank you.